Hello, today's lesson is 4.6 completing the square. Today's objectives are to solve equations by completing the square and to rewrite functions from standard form into vertex form by completing the square. Lesson vocabulary, completing the square. It's very important that you understand that completing a perfect square trinomial allows you to factor the completed trinomial as the square of a binomial. This extra credit project was done 4 years ago by Nicolette Bingham and Irina. Before we can use completing the square, we need to remember how to find solutions by square roots. So what is the solution of each equation? Let's start with the first one. In order to solve it, first I subtract the 5, then divide by 3. Then I have to take the square root of both sides. So what I have, x equals plus and minus the square root of 5. Please be careful to always use plus and minus because both negative square root of 5 and the square root of 5 is going to yield 5 as the answer, because square root of 5 times square root of 5 equals 5, and also negative square root of 5 times negative square root of 5 is also 5. B, again, I have to add the 3 to both sides, then divide by 8. Then I have to take the square root of both sides, making sure I don't forget the plus and minus sign on the right hand side. X equals plus and minus 2. Why plus and minus? Again, 2 squared is 4 and negative 2 squared is also 4. The two solutions are in a brace. This is the list of solutions, negative 2 and 2. Let's use finding the square root in a word problem. Total area of 3 congruent circles is 500 square centimeters. So we have to find the approximate radius of each circle. The area of a circle, pi r squared. Area of 3 circles, or 3 times that many. So I write 3 pi r squared equals 500. That's the information that was given to me in the word problem. Solve for r. First I have to solve for r squared. So r will equal, I square root both sides. Now realize that this time I am not using the negative sign, because it's a real-life application. I cannot get negative numbers for the radius of the circle. Using my calculator, I plug this in and I get approximately 7.28 centimeters. Objective solving by finding the perfect square trinomial. As we see here, x squared plus 12x plus 36 is a perfect square trinomial. X plus 6 squared equals x squared plus 12x plus 36. So by taking the square root of both sides, I get x plus 6 equals plus and minus 3. Then obviously there are two equations. X plus 6 equals 3, so x equals negative 3. Or x plus 6 equals negative 3, which gives me x equals negative 9. Let's complete the square. If I am given an x squared plus bx, so you can see the c is missing, and I try to make that into a perfect square trinomial. So let's try to draw a square. X times x is x squared, so I'm good. And this is b times x. This doesn't look like a square, so I'm going to halve the b. I put it on one side and the other side. Now I do have x squared plus bx, but this is missing. b over 2 times b over 2 is missing. As soon as I add that, I have a perfect square of x plus b over 2 squared. Let's use this. What value completes the square for this? Remember, this is x squared plus ax squared plus bx. So I'm missing the c term, the constant term. So what is going to complete the square? I have x times x is x squared. I halve the b term, 7 and 7. What's missing here? 7 times 7 is missing, which is 49. So 49, which is 14 over 2, which is this over 2 squared, is missing, which is 49. Let's solve an equation by completing the square. Stop the video and read these steps. You need to understand and know these steps in order to comfortably solve these type of equations. First of all, I realized that this and this and this all have 3 in common. So the first step, I am not going to work with big numbers. I am going to divide every term by 3. Isn't that lovely that now I have x squared plus 6x minus 1 instead of 3x squared? I do not like to have anything in front of my leading term anyway. So to complete the square, first I add 1 to both sides, so I only have to deal with the x squared plus 6x part. Then I draw my circle. X squared is x times x. I half 6x, so I put 3x here, 3x there. So 3 times x is 3x. 3 times x is 3x. What's missing? A 9 is missing. So I'm going to add the 9 to both sides. You remember the formula, half of this squared is what I need to add. Half of the b squared, half of 6 is 3, 3 squared is 9, so I add this to both sides, and now I know that this is x plus 3 squared equaling 10, taking the square root, plus and minus. I solve that x plus 3 will equal the square root of plus and minus 10. By subtracting 3, I get negative 3 plus and minus the square root of 10. So in a list, it's negative 3 minus the square root of 10 and negative 3 plus the square root of 10. This is another completing the square exercise. However, now I want this function from standard form into vertex form. Remember, we have done that before earlier with negative b over 2a and then plug this back into the original equation. Now we're going to use completing the square to do exactly the same. Let's write the equation. Then remember, in order to complete the square, I need to take half of this, which is going to be x minus 5 squared, but I needed to add 10 over 2 squared, which is again half of this squared, so I have to subtract it at the same time also. So what I have left is x minus 5 squared minus 25 plus 4, which simplified x minus 5 squared minus 21. Do stop the video and understand what I'm doing here. This is the formula. What I do, I add b over 2 squared here, but I cannot just change the value of a function. I can't do that. So I'm adding this as well as I'm subtracting it. So this is actually 0. Why am I adding? So that this square is complete. This is the complete square of x minus 5. So this function, this is in standard form, and this one will be in vertex form. This is the end. Now completing the square is not easy. You might have to practice many problems, but I really hope that you understand and know the concept by now.